So in our last class, we introduced the idea of an inequality, why we would care about an inequality using this particular word problem about what test average a person would need in order to get a 70 average over all 3 tests. So we ended up translating this paragraph into an inequality, and then the task for us was to solve that inequality. And the good news is that from there, the process that we used to solve this inequality was the very same strategy. It was to use the very same strategy as when we solve an equation, which is first of all to simplify both sides of that inequality. So on the left-hand side, we simplified that out by breaking out the 132 divided by 3 plus the x over 3, and so we ended up with this. And then the simplify both sides step was done. Then collect all variables to one side. We didn't have to do that here, but if x appeared on both sides of the equation, we would use a subtraction to move the x's from one side to the other. So step 1 and step 2 were both done. Then all we had to do was reverse the order of operations. Subtract 44 from both sides, and then multiply by 3 on both sides, and that's where we ended up. So in the example from Monday, it didn't matter to us in the process that we were solving an inequality. All of the steps that we took were exactly the same steps as if this had been an equal sign instead of a greater than or equal to sign. So that's the good news. The bad news is that there's one wrinkle in that we didn't experience in this problem, but which I want for us to experience together over the next few minutes. So this inequality, 18 is greater than or equal to negative 2 minus 5w. We'd like to do what we did before and solve this inequality. Get the w by itself and figure out what range of values for w will meet this condition. So if you imagine for a minute that here's the real number line, here's the number 18, and this is telling me that 18 is greater than or equal to negative 2 minus 5w. So that must mean then that wherever the quantity negative 2 minus 5w is, it must be to the left of the number 18 on the number line, because 18 is greater than or equal to these values for w. So those w's that we want are those for which negative 2 minus 5w is over here. With what kind of a circle up here at 18? Yeah, there we want a closed circle because it's greater than or equal to, so 18 could be equal to negative 2 minus 5w. So this is kind of what the setup of the problem looks like. What we want to do is do the algebra that would be necessary to get us to figure out where w must live based on this information. So we'll simplify both sides of this inequality. Both sides are already totally simplified as much as we can, so there's nothing to do. Collect all the variables onto one side. Well, that's already also done for us at the beginning of the problem. There's only one place where the variable happens, and it's only on this one side of the equation. So all we need to do to get that w by itself is to reverse the order of operations. So what step do we want to do first? If I'm trying to unwrap the w, what's my first move? Add 2 to both sides, right. So the first thing I want to worry about is adding and subtracting, because we're reversing the order of operations. So I'll add 2 to both sides. That will get rid of this minus 2 from the right, and I'll turn the left-hand side into 20. And so my new inequality is going to look like this. 20 is greater than or equal to 5w, negative 5w. And then what would be my next step? Divide by negative 5. Yeah, don't forget that minus sign in front of the 5. It's making the coefficient a negative number. So we'll divide both sides by negative 5. 20 divided by negative 5 is going to give me negative 4. And then these negative 5s over here annihilate one another, which is the whole point. And so I get just plain w. And so I end up with a solution that looks like this. If I write that in words, it says negative 4 is... What is this sign in the middle here saying? Greater or equal to w. Which is a little bit of a clumsy way to say it. Usually when we write down an inequality solution, usually we'll put the variable first because it's the subject in our sentence and the rest of it's kind of the predicate. So if I wanted to rewrite this in a way that puts w first, how would I write that? Less than or equal to negative 4. Yeah, great. So that's another way to write the solution that we just got here. So let's diagram that out. We could also use interval notation, but maybe I'll wait on that for a second. So what this is kind of saying is that somewhere down here is the number -4 on the number line. And if I shade the number line there to the left, then those are the w's that are going to satisfy this inequality, with a closed circle up here at the top, and this goes on infinitely far in that direction. Okay, so this is the answer that we get by using the same process that we used on Monday. Let's check to make sure that this worked. Checking your answer, the most underrated skill in all of algebra, because if you catch your mistakes, you can fix them. If I catch your mistakes, then you have to do the problem over again in a revision later on, right? So it's better that you catch your mistakes than that I catch your mistakes. So how might I test this? What's one way that I could test and see whether or not this inequality that I've diagrammed here is actually a solution to the inequality that we started with? Okay, so one thing I could do is pick any element which belongs to this green set. So I could pick -4, for example, and then just plug it back into this inequality and see if I get a statement which is true. So if I use -4 for w, let's see what it tells me. So if I substitute -4 in for my w, I'm going to do that with some parentheses. Remember, anytime you're substituting for a variable, include it in some parentheses so that we don't screw anything up. And then do the arithmetic on this right-hand side. -5 times -4 is +20. So I'm adding 20, -2 plus 20, that's 18. Is it a true statement that 18 is greater than or equal to 18? That's true. So at least for the number -4, we seem to get yes, that the number -4 actually meets this inequality. But remember, this solution set doesn't only contain -4, it also contains all these numbers that are less than, to the left of. So we should check one of those too, just to be sure that we didn't miss something. So give me an example of a different number that I could check that belongs to this set. Yeah, -3 is here, but -5 is there. And -5 would seem to belong to my set. So let's try -5 and see what happens. So again, blot out that w, empty parentheses, put in a -5, and then do the arithmetic. -5 times -5 is going to give me +25, and -2 plus 25 is going to give me 23. Is it true that 18 is greater than or equal to 23? Uh-oh, it's not true. So something has gone wrong in our process. So just to kind of note it down here, this -5 is not, in fact, a solution. Okay, how about this -3? Let's try it. It's not a part of our solution set, but I just kind of want to try it just for kicks, just for fun. If I try putting into my original equation, this was -2 minus 5w, right? If I try putting -3 in, let's see what happens there. -5 times -3, that'll give me +15. -2 plus 15, 13. Is it true that 18 is greater than or equal to 13? It is true. So what happened here? How come the strategy that we used gave us an interval for our answer that somehow seems to point the wrong direction? That it left out the number -3, which it turns out is a solution, and it included a number like -5, which it turned out wasn't a solution. Which was the step in our order of operations reversal where something happened that we didn't expect? What do you think? We only did 2 steps to reverse this order of operations. We added 2 to both sides, and then we divided both sides by -5. Let's look at the picture one more time. I want to add an intermediate picture in the middle. When I added 2 to both sides, I ended up getting a new inequality in the middle that had 20 as its point of comparison. So I'll sort of slide this over here, 20. And then it had the expression -5w. So let me shade that part in. And the inequality sign was still kind of facing to the left, so we ended up with a picture that looks like this at our intermediate stage. So in pictures, what we kind of did going from this first inequality, let me rewrite that first inequality there again, going from this first inequality to the second one, is we really just took the whole number line and we shifted everything over to the right by 2 units. We just moved it, slid it right on over. Okay? And if all we're doing is sliding something to the left or to the right on the number line, we're not really flipping it, right? We're just sliding it. So what used to be less than remains less than. What used to be greater than remains greater than. So at that step, it looks like we're okay. But something interesting happens when we divide a number by a negative. That when I divided 20 by -5, we ended up getting -4. But in doing so, we flipped all of this stuff from one side of 0 on the number line over to the other side of 0, right? I put the 0 in kind of a bad place. Let me put it over here instead. So we flipped to the other side of 0. So we passed through the looking glass, in a way. Right? One way to say it is that a number which was previously larger before we flipped it across 0, once I flip it across 0, -20 is actually less than -18. Right? Because less than means to the left on the number line. Greater than means to the right. So even though 20 was bigger than 18, if I flip those two things over by making them negative, -20 becomes less than -18. So it is that step right there. When we divide both sides by -5, we not only change the quantities on either side, but we also need to change the sense of the inequality, the direction of the inequality. There are other occasions in which to do that too, that my math major that asked me the question this morning was more concerned about, but this is the one that we see the most often in an algebra setting. The -4, by the way, was still a solution. We actually checked it directly. But the difference is that it's not the numbers less than -4 which are solutions. It now becomes the numbers greater than -4. And so I'm just going to leave you with this. That this is the step right here where the greater than or equal to sign that we had needs to turn around into a less than or equal to. And the rubric for that, the way to remember, which then if I switch this around becomes greater than again, is that anytime we multiply or divide by a negative, so it's not the fact that this 20, if this 20 had been negative instead and this 5 had been positive, we wouldn't switch the sign. It matters what we're dividing by. So if we're dividing by a negative number, like my -5 here, then we need to flip the sense of the inequality. That's the bad news. The good news is that's the only modification we need to make to our strategy for solving equations to turn it into a strategy that can solve inequalities. Other than this one caveat, there's no other reason to deviate from the strategy that we are accustomed to using. And the subtext, the sub-moral of the story is, remember to check your answers. Because if we hadn't checked this answer, we might not have realized that we forgot to flip that sign. So take that power into your hands so that I don't have to take it into mine when I grade your work.